Welcome, Hornets, and thank you for joining me. We are now going into part 2 of our classwork or assignment number 12. Assignment number 12 is found on page 453, and we're looking at currently numbers 1 through 22, and I have already done numbers 1 through 10 in the previous video. We're going to be taking a look at numbers 11 through 22 in this video, and then I will go to part C, do 25 through 29, and then 41 through 48, and then 72. So just be aware this is part 2, and we are starting with number 11. Number 11 is asking us to find the volume of the figure generated when we revolve around certain axes. So, for example, in our first one, we have 11, y equals the square root of x. We're going at y equals 0 and x equals 3. I'm going to start by taking a look at what this looks like. We have this value going like this. We're going from x equaling 0 to x equaling 3. You'll notice that this is going to give me the point 3 comma root 3. And I'm just going to go ahead and say that this is also x equals y squared. We're starting at 0. Now they want me to start off in A, finding the volume when we revolve around the x-axis. So if I'm revolving around the x-axis, I have pi integrated from 0 to 3, and I'm working with the square root of x, the quantity squared dx. This is giving me pi integration 0 to 3 of x dx, which is pi 1/2 x squared from 0 to 3, and my answer turns out to be 9 pi halves. B is asking me to revolve around the y-axis, which means I'm now looking at this portion of the curve. Oh, no, okay, no. So I'm still looking at this portion, but now you'll notice it's going to be the washer method. So I have an upper minus lower, upper minus lower. This value right here is 3 comma y. This value down here is 0 comma y. And this point right here is my y squared comma y. So the big R of x is 3 minus 0 for 3. The little r is going to be y squared minus 0 for y squared. And we're looking at pi integration. We're going from 0 to root 3, and I have this 3 minus, it's 3 squared minus y squared squared dy. This is giving me pi integration 0 to root 3 of 9 minus y to the 4th dy. Putting this together gives me 9y minus 1/5 y to the 5th from 0 to root 3 pi. The zeros are all going to cancel, so that's not an issue. But I do have a 9 root 3, and I'm going to subtract another 9 root 3 fifths. And this is multiplied by pi. To get my common denominator, I'm looking at 45 root 3 fifths minus 9 root 3 fifths, which is leaving me with 36 root 3 fifths, fifths pi. This brings me to C. C now wants me to do this, but around the line x equals positive 3. So I'm going to just go ahead, I'm going to redraw my figure. That's what I'm looking at. And we're looking at x equaling 3, so that's this axis right here. We find the segment. Notice this is my r of y, and the r of y is going from 3 comma y all the way down to this point here, which is y squared comma y, and therefore my r of y is 3 minus y squared. Doing my disk method, I have 0 to root 3 of 3 minus y squared dy. As I now do this, I'm looking at 9 minus 6y squared plus y to the fourth from 0 to root 3 multiplied by pi. Let's make sure I integrate this. Oop, forgot to integrate. Let's make sure I do that. So even I can kind of make a silly mistake if I'm not careful. 9y minus 2y cubed plus 1/5 y to the fifth from 0 to root 3 multiplied by pi. 9 root 3 minus 6 root 3 plus 9 root 3 fifths. This is giving me 3 root 3 plus 9 root 3 fifths, which is 15 root 3 fifths plus 9 root 3 fifths is going to make a total of 24 root 3 fifths. And don't forget to multiply by pi. And notice they're just having you go through and try all of these different figures. Now the last figure is working with the line x equals 6. And if you think about what this is going to look like, here's the 6 over here. Here's the figure we're working with. And you'll notice I have the washer method. And this is because the axis of rotation is not one of the sides of the figure. So here we have 6 comma y. This right here was 3 comma y. This point down here was y squared comma y. We have a big R and a little r. The big R of y is 6 minus y squared. The little r of y is 6 minus 3. This is giving me pi integration. Keep in mind that, let's see, we are still integrating from our 0 up to root 3. Again, perpendicular to the axis of rotation. We have our big R, which is 6 minus y squared minus 3 squared dy. Simplifying this is 36 minus 12y squared plus y to the fourth minus 9, which is giving me 27 minus 12y squared plus y to the fourth. And integrating this gives me 27y minus 4y cubed plus 1/5 y to the fifth from 0 to root 3. Then multiply by pi. 27 root 3, we have minus 12 root 3 plus 9 root 3 fifths multiplied by pi. We're looking at 15 root 3, which is going to give me 75 root 3 fifths plus 9 root 3 fifths is going to give me 84. So I have 84 root 3 pi fifths. And there is my answer to number D from number 11. Now, they expect you to do them again and again and again. So they want you to next do number 12, then do number 13, and then do number 14. Now I'm going to move to number 13. Number 13, we only have to do two things. That's the nice thing. This is around the x-axis and the line y equals y equals positive 6. So I'm going to start by graphing this. I've got a quadratic going like this. And then I have, let's see, x-intercept is 0 and 4. 0 and 4 all the way up here. And this graph is doing something like that. Okay, so here's the 4 intercept. Looks like it's a 2, Mr. Lamb. Let's make sure we get that correct. So let's just make sure if I put in a 2, so I've got x times 4 minus x. It is, yes, 0 and 4. But we want this point of intersection. So I'm going to go x squared equals 4x minus x squared. 2x squared minus 4x equals 0. That factors 2x out, leaving me with the x minus 2 equaling 0. And I now know that I have 0 and 2. This point is therefore 2, 4. Let's just get rid of that. And I'm trying to revolve around the x-axis here. So I'm taking from 0 to 2. I have an upper and a lower. The upper is the 4x. So we have x comma 4x minus x squared. And the lower x is going to be x comma x squared. So I'm able to find my big R of x as 4x minus x squared, the quantity squared, and I'm subtracting the x squared, the quantity squared, dx. Now we're going to simplify it so that we can figure out what we have. We have 16x squared minus 8x cubed plus x to the 4th minus x to the 4th dx. These cancel. So I have 16 thirds x cubed minus 2x to the 4th from 0 to 2 multiplied by pi. And this is giving me 8 times 16 for 128 thirds minus 2 times 16 for 32. Just make sure I'm not doing anything silly. I've got to make sure I'm being very careful. It is very easy to make silly mistakes, and I do not wish to make them. I end up getting 32 thirds pi as my final answer. Then we go to B, which is doing the same thing, but now we're revolving around the line y equals 6. So there's my figure. The line y equals 6 is all the way up here, y equals 6. So we have a big and a little r. Notice we're now changing the orientation. This is x comma 6. This piece is x comma x squared. That piece is x comma 4x minus x squared. So we're now going to have to set this up. We have pi integrated from, once again, we're going from 0 to 2. And I have my 6 minus x squared squared minus 6 minus 4x minus x squared squared dx. Now you notice we're going to have to FOIL this out, so we have 36 minus 12x squared plus x to the fourth. When we FOIL this, let's do it vertically, then distribute the negative. Otherwise, you will make a mistake. This is the place where most people will make them. So I have a positive x to the fourth, a minus 4x cubed, a minus 6x squared, a positive 4x cubed, a positive 16x squared, and a negative 24x. We have another minus 6x squared. We have a minus 24x and a positive 36. So x to the fourth, those are canceling. 12 from the 4 gives me a positive 4x squared. I have a minus 48x and a 36. And this is what I'm going to have to add. So I want to distribute the negative. And now I'm going to add 36 minus 12x squared and a positive x to the fourth. Those cancel. 36 cancels. So I've got, let's see, 48x minus 16x squared. And this is from 0 to 2. Whoops, let's put our dx in and actively integrate 0 to 2 pi. We're now going to simplify this. So I'm looking at 48 divided by 2x squared minus 16 thirds x cubed from 0 to 2. This is giving me 24x squared minus 16 thirds x cubed, 0 to 2 multiplied by pi. And I'm looking at 4 times 24. I'm looking at 96 minus 16 times 8 thirds is 128 thirds. Then we do 96 minus 128 thirds, written as a fraction, and I get 160 thirds pi. And there is my answer, and that is number 13. Now you should already start to realize that a lot of this is just going through the process. They're going to ask you to revolve around various lines. So number 15, for example, you have y equals x, y equals 3, and x equals 0. Let's draw this. Y equals 3 is a horizontal line. X equals 0 is that vertical going across. And then we have the slanting line here. We're revolving around y equals 4, which is up top. And once again, we can clearly see we're doing the washer method. Let's make sure we do the correct segments. There you go, Mr. Lamb. This right here is x comma 4. This is x comma 4, x comma 3. This piece is our x comma x. And so my big R of x is 4 minus x. My little r is going to be 3 minus x, 3 minus 4, excuse me. Try that again, 4 minus 3. 4 minus 3, which is just giving me 1. pi integration, and we are going from our 0, and let's see, it looks like we're going up to x equals 3, and there went my lights, of course, 0 to 3, and we're now putting this together as 4 minus x, the quantity squared, minus 1, the quantity squared, dx, for 16 minus 8x squared minus 8x plus x squared minus 1, 0 to 3, pi dx. This is giving me x squared minus 8x plus 15 dx integrated 0 to 3 times pi, 1/3 x cubed minus 4x squared plus 15x from 0 to 3. We only care about the 3, so I have 9 minus 36 plus 45, and that's going to give me 18 pi. So my answer is 18 pi, and that's 15. Alrighty, I'm going to go ahead and I'm going to stop here. Thank you, Hornets, and have a very good day. We will talk to you later. Please be well and take care, and I'll do part B. I'll do part 3 of our video in just one moment. Thank you, Hornets. Be safe and take care. Bye-bye now.